All right, last video for the semester. For this one, we are going to talk about factoring polynomials. There's a lot of information on this, so I just kind of need you to pause this and write a lot of it down. This is just kind of describing how a quadratic is a type of polynomial. So they share a lot of the same features. Just like we factor quadratics using the star method, we also factor polynomials. The star method is one of the methods we use, but there's also 3 new methods that I have to show you. This little reminder over here, you need to remember this won't always happen, but it will pop up in some problems. You do need to look for greatest common factor, so look at every single term and see if they have something in common that you can pull out before you start factoring. So before we actually start factoring, we are going to decide whether something is a factor. You can do this using synthetic division or long division. Remember to use synthetic division. There cannot be a number in front of your x. So I'm just going to go ahead and set up synthetic division. I do see a hole in this problem, so I have 5x to the third plus 1x squared plus 0x minus 7. So I'm going to set this up. I'm going to put a positive 2 inside the box since it's x minus 2. And then on the outside goes a 5, 1, a 0, and a negative 7. So follow the steps. I bring down the 5. 5 times 2 is 10. So that's 11. 2 times 11 is 22. So I add that together. And 2 times 22 is 44. And negative 7 plus 44 is 37. So my remainder here is 37. The only times that something is a factor is if your remainder is 0. So my answer here is just no. X minus 2 is not a factor. And that's all there is for problems like those. So this is your try your own for that type of problem. From here we'll get into actual factoring. The star method. You have seen the star method before. Again, polynomials have a higher degree than just 2. So I can use the star method for anything that follows this pattern. I have x to the 2n plus x to the n plus c, which really just means I have an even exponent first. Half of that exponent is the middle term, and then a constant is your last term. So for example, over on the side, I have written out a couple that it works for, like x squared, x and a constant, or x to the fourth and x squared and a constant, x to the sixth, x to the third and a constant, and so on and so forth. So it has to be an even exponent, then the exponent has to be half of that, and then the constant term. So in our example, I have x to the sixth minus 10x cubed plus 25. Again, I follow the pattern of an even exponent, half of that, and then my constant. There's no GCF, so I'm going to start with a is 1, b is negative 10, and c is 25. So a times c is at the top, and b is at the bottom. My two numbers that will multiply to positive 25, but add to negative 10 would be negative 5 and negative 5. So my answer here is x minus 5 and x minus 5. But if we notice, I started out with 6 x's. So in order to have 6 x's at the end, I'm going to have x to the third minus 5 and x to the third minus 5. So again, you're going to take half of the exponent you started with, and that's going to go in each of your factors. So if I were to multiply this back through, it would end up with x to the sixth minus 10x to the third plus 25. So that's factoring a polynomial using the star method. The next way of factoring, we actually have seen this before as well. I taught you just using the star and then kind of told you guys about this shortcut. So the difference of two squares. So this can only be used on any polynomial where you're subtracting two perfect squares. So down here I listed off what a bunch of your perfect squares look like. For numbers, it's 1, 4, 9, 16, 25, 36, so on and so forth. For your variables and exponents, it's any even exponent. So here I have 4x squared minus 9, which is a quadratic because it just has a degree of 2. So remember, your difference of two squares, you're going to take the square root of each piece. So the square root of 4x squared is 2x. And the square root of 9 is 3. Then what you're going to do is you're going to add one set and subtract the other. So that is your difference of two squares. Example number 4 we'll actually do in class together. So you just need to get example number 3 down. Perfect cubes. Difference of two squares you can only do when you're subtracting two perfect squares. Here, you can do this anytime your problem consists of perfect cubes. So it doesn't matter if you're adding or subtracting. So if you notice in this first problem I'm subtracting, the second problem I'm adding. I can still do it. Just like with the perfect squares, I went ahead and wrote the perfect cubes up here. Again, I think these are super important for you to at least have in your notes and have a good idea of kind of memorizing them, just because the sooner you recognize them, the easier these problems will be. For example number 5, x to the 6th minus 27. Both of those fall in my list of perfect cubes. So I'm actually going to follow this equation. So the a to the 3rd and b to the 3rd is the x to the 6th and the 27. So I'm going to use this equation of ab, then a squared, ab, b squared. This is something you're just going to have to kind of memorize and know. So if I start with x to the 6th, the third root of x to the 6th is actually x squared. And the third root of 27 is 3. So if if a is x squared, then that means a squared would be x to the 4th power. ab would be 3x squared, and b squared would be 9. So again, it's important that you figure out what a and b are, and then from there you can just multiply them together. This second part down here says for the signs, always use SOAP. What SOAP stands for is same, opposite, and always positive. So I'm going to look up at my original problem. My original problem was a minus. So my first sign is going to be the same. My second sign is going to be the opposite. And my last sign is always positive. Just like with the perfect squares, example 6 for the perfect cubes, we'll do that in class together. The last method to factor polynomials is factor by grouping. You use factor and grouping on any polynomial that has 4 terms. So 4 terms, you're always going to use factor by grouping. The process, there's really just 2 simple steps. You're going to split the polynomial in half, then you're going to take the GCF of both halves. So looking at example number 7, first thing I'm going to do is split this polynomial in half. So the front half I look at, y to the 3rd minus y squared. They have a y squared in common, and I'm left with y minus 1. On the back half, I have a negative 4y, and that's actually a typo. That y shouldn't be there. Instead of a y, it should have been a 4. So it should say negative 4y plus 4. They both have 4 in common, but again, just like when we talked about with quadratics, my first term can never be negative. So I'm actually going to pull out a negative 4. And that's going to again leave me with y minus 1. The only way factor by grouping works is when you pull out the GCF of both halves, you're left with the exact same thing inside the parentheses. Because then what happens is I can group that into just one parenthesis, and I take what is out front, so this y squared and then negative 4, and that's going to create my other parenthesis. So that's how factor by grouping works. I split it in half, take the GCF of both halves, write the GCFs in one parenthesis, and write what was left in the other parenthesis. I'm not quite done with this problem though. Y squared minus 4, if you recognize that, is actually the difference of two squares. Y squared is a perfect square, and so is 4. So this will factor down to y plus 2 and y minus 2. And then I still have to bring down that y minus 1. So this is actually the completely factored polynomial. Just like the other problems, don't worry about example 8. That is what we'll do in class together.